Welcome, Algebra 2 students, to the Homework Cup video, page 105 and page 112. Let's jump into this right away. Here we go. Please take really good notes and rewind parts of the video that you feel like you do not understand. Here we go. A music group's new album is released. Weekly sales, as in thousands, increase steadily for a while and then decrease, and that makes sense. When a new song comes out, excuse me again, sorry. When a new song comes out, it increases in popularity, then eventually tapers off and goes back down. Okay, and by the way, look at that. Is that not a picture of an absolute value function? Sure it is. All absolute value functions graph a perfect V. Sometimes they open up, sometimes they open down. Okay, just like movies. Movies come out and they're really popular, and then they start to decrease in popularity as other movies come out. Okay, so that's what we're looking at. So they give us a model of this, of the sales of this new album. Okay, so T is in weeks. So in other words, I could put in right here week number 3. I could put a 3 in for T right here, and out would come the sales. For that week. Okay, so make sure we understand that. All right. Okay. So moving on. First of all, they want us to sketch the graph. I'm going to do this relatively quickly. We've done a lot of these, so here we go. You take the inside of the absolute value, set it equal to 0, and solve. So there's the x value of your vertex. Let me say that again. You take the inside of the absolute value, set it equal to 0, and solve. That gives you the x value. Then we go up 23, 24. We'll go down 21, 20. Put these numbers in quickly. 2, negative 4. You would get out of 40. I'm doing most of this quickly in my head. 23, 1, negative 2. 42, 22, 0, 44. If you put a 21 in, trust me, you will get 42. If you put a 20 in, you will get a 40. So I'm not going to graph. I'm not going to graph this. You can do it on your own. I will tell you what I would do for the increments. For the increments of x, I would definitely go in increments of 1, even though it goes all the way up to 20, because these here are in increments of 1 too. So I would like put a little hitch mark here and just start it at 10. Or no, I would start it at like, I don't know, 19, and then put 20, 21, 22, 23, 24, and then going up, same thing. I would put like a little hitch mark here, just make a note that I'm starting at 38, 39, 40, 41, 42, and 43, 44, and you can quickly draw the graph, and it would look, something like this. Okay, so there we go. Now, I will say this, I did think of one thing that I probably should correct myself on. If you're truly going to graph this, probably, I'm going to correct myself on this, and we all make mistakes, guys. If I was there in class, I would say, oh, hold on a second, since it is a word problem, I will say this. I would definitely find the vertex, like I did right here, 22, 44, okay? But I probably would put in 0, and that would give me out 0. I'd want to see the starting point before the sale started, and then we know this model is good for how many weeks? 44 weeks. So I would probably put a 44 in right here, and that would also give me out a 0. That's how I would graph it, okay? Because, come on students, think. It's really good to have the first point being when the sales started. That's week 0. And it's good to have the ending week when the sales were bottoming out, okay? So, I'm going to slide this out of the way just for a quick second. That's how I would graph this word problem. And so, I would put a 0, 0 here. I'm going all the way up the, let's see, on my x-axis all the way to 44. So I would do it in increments of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45. So I'd have a point here. And then my vertex is over 22 and up 44. So 5, 10, 15, 5, 10, 15, 20, 22, and up to about right here, and there's my fee. That is the right way to graph it. I apologize for not thinking there for a second. I do work these problems out ahead of time, but the graphing part I did not, because it just seemed to be common sense how to graph it. But if we're done with word problems, it's really good to have a starting point, the vertex and the ending point, and notice you would not continue on and go like this, like you're used to doing, because you can't have negative sales of records. I mean, you can have negative profit, but that's different than having negative sales. How many records were actually bought? Okay, so all right, let's continue on. Now the next part is estimate the total numbers sold during the first 44 weeks. Now here we go again. I probably should have left that graph up here. All right, now let me pull this down here. Get a new page, go here, grab this, and pull it here. And here we go. Now, estimate the total number of albums sold during the first 44 weeks. Now, I mean, here's what you could do. Are you ready? You could put a 1 in for this equation here. Put a 1 in, get out a total for week 1. Put it here. Then put a 2 in, get out a total and put it here. Then a total for week 3, total for week 4. And do that 44 times. Then add all of those up. That's going to take you quite a while. But I've got a faster way, and we learned this in our notes. Think about it. I'm counting by fives here. So week 5, I have a total of how many albums were sold here in week 5. Looks like, I'm just making this up. Looks like about 5. About 5. A little more than 5, maybe 7. Now I think it says it's in thousands. Okay, so look at my graph. In week 5, I sold about 7,000. And in week 15, I sold about 5, 10, 15, 20, 21,000. So what? Every time you come across a little point here, you're finding the height. Every time. Every time you're doing that 44 times. Well, guys, you're covering up this entire area is all that you're doing. So a lot faster than doing all 44 weeks is just find the area of this triangle. That's all you got to do. And that's what we learned in our notes today too. So to find the area of this triangle, I need the formula for the area of a triangle. 1/2 times the base times the height. Well, here is 0, 0. Here is 44, 0. So I go from 0 to 44. So my base is 44. My height is how high? Well, think of your vertex. The vertex is 22, 44. So we're over how far? 22. And we're up how far? 44. So what's the height then going up? 44. Let's look at it again. You go over 22, up 44. Your height is 44. Alright? Now, base times height. Let me grab my calculator here. 44 times 44. Divided by 2. And you get 968. So if you take 1/2 times 44 times 44, you get 968. But hold it. It's in thousands. So there's the total. This total is not for week 1. It's not for week 2. It's not for week 3. This is all 44 weeks added up together. So about 968,000. Okay. Now it says, did the album go gold? Did it go platinum? Well, guys, I'm about as old-fashioned as they come. I don't even know. I'm pretty much Southern gospel and that kind of stuff, so I don't even know what that gold and platinum stuff is, but I'm turning in my book now to page 105, and I'm looking here. It probably says something off to the side. Yes, here it is. If you'll look on page 105 underneath the picture of the guy who is singing and sweating profusely, it says here, it's a gold album if he sells over 500,000 copies. It's a platinum if he sells over 1 million. Well, we did not make 1 million, but we did sell over 500,000, so the answer is it was a gold record. Okay. Number 47, would the group have sold more albums during the 44 weeks if it had sold 20,000 albums per week? Well, that's an easy multiplication problem. Let's see. If he had simply sold 20,000 albums per week, would he have sold more? I'm not going to worry about giving a geometrical interpretation of your answer. That's just getting into comparing areas in a rectangle and a triangle. That's not necessary. It just simply says if I sold 20,000 albums every week for 44 weeks, I would get 880,000. Well, how many did he sell? 968,000, or she, whatever. So, did they sell more? Absolutely not. No, definitely not. They would have sold this many, which is less than this many. So the answer would be no. And the answer to the 6 was gold. Alright. Okay, let's continue on. You are trying to shoot the 8 ball into the corner pocket as shown. Imagine that a coordinate plane is superimposed over the pool table so that the points 10, 0, and 0, 5 are the two corner pockets. The 8 ball follows the path given by this absolute value function. Do you make your shot? Okay, no problem. Let's have some fun with this. Here we go. Okay, we have superimposed sorry about that. We have superimposed a coordinate plane over the pool table so that 10, 0 and 0, 5 are the two corner pockets. So 10, 0 is right here, and or 0, 10 is right here, and over here would be 10, 0 right here. So here's my coordinate plane. There's my coordinate plane, okay? And there's the vertex right there. And here's my absolute value graph right here. Alright, now here's what it asks. Will you make your shot? Okay, well, let's find out. Here is my absolute value function. Now, this is really not a difficult problem. Watch this. If I'm going to make my shot right here, then this ordered pair right here had better satisfy this function. In other words, this ordered pair right here had better fall on the graph. Now, using the naked eye, just looking at it, looks like it does, but we're going to make sure. Now, what is this pocket called right here? Well, we know we're over how far. Excuse me, I said what is this pocket called? Let me refine my question. What is the ordered pair of this pocket right here? Well, it's over how far? 10, and it's up how far? 5. If this is up 5, then this is up 5 also, because the pool table is rectangular. So over 10, up 5. So I'm over 10, up 5. Okay? Now the question is, does this ordered pair satisfy this absolute value function? If it does, then yes, the ball's going to go in. If it doesn't, if this ordered pair does not fall on this graph, then no, the ball's going to follow the graph, and it's not going to go in this pocket, because this pocket, this ordered pair, is not on the graph. So let's see if it satisfies this equation. Are you ready? Where the x is, I'm going to put a what? 10. And where the y is, I'm going to put a what? 5. Let's see if I get out a true statement, okay? 5 equals 5 fours times 10 minus 6 is 4. Okay? Now the absolute value of 4 is 4, and 5 over 4 times 4 is 5. So you get out 5 equals 5. Check. So yes, this point does satisfy this absolute value function right here. So yes, it does lie on the graph. So yes, your shot will go in. Okay? Now, next they want us to sketch a graph of the equation. I'm not going to do that because they've already done it for us. I mean, guys, it's right here. Come on. I mean, we got a coordinate plane and everything. So I'm not going to worry about that. At what point does the 8 ball bank off the first side of the table? So they want to know what this ordered pair is right here. When the ball comes off the stick and hits the first side, what is that ordered pair right there? Right here. ask you a question. Is not this ordered pair the vertex of the graph? Of course it is. So all that I have to do is find the vertex of this right here. And then that has to be this vertex here, and I'll have the ordered pair. So let's find the vertex. This should be pretty simple. We know how to find the vertex, don't we? Take the inside of the absolute value, set it equal to 0, and solve. So there we go. So my vertex so far is 6, comma. Now, we look at the number on the outside here. Is there anything being added or subtracted outside of the absolute value? No, there's not. So we can put plus 0 if we want to. So we put a 0 here. So that's the vertex. The vertex is 6, comma, 0. And there we go. That is the answer. Okay. Alright, moving on to number 57 and 58. These are pretty tough problems here. When a traffic light turns green, you accelerate at a constant rate to a speed of 60 feet per second, or about 41 miles per hour. Then you decelerate because you see the light in front of you is turning red, so you steadily at a steady rate to a stop at the next traffic light. Your speed in feet per second is given by this model right here, where t is time in seconds. So we write the model right here so we can do some writing on it. Let me talk to you about this model. Let's bond and become one with this model. Just kidding. Alright, now I can put like 10 seconds in for this. And at that point, it will tell me the speed that I'm going at that rate. Okay? That's all that it's doing for me. Got it? So, first they want us to sketch the graph. Now, let's quickly find the vertex here, okay? We can take t minus 6 and set it equal to 0 and solve, and we get 6. So the vertex would be 6, comma, here's the number on the outside being added or subtracted. 60, so there's my vertex, okay? Now, I want to start at 0, 0, guys, I really do. So for my table of values, I'm going to put 0 in. Actually, it wouldn't be 0, 0, I don't think. Let's see. Yeah, it would be. My vertex goes in the middle. I'm putting 0 in for x. Now, I know I've taught you to put 5 ordered pairs and put 7 and 8 here and 5 and 4 here. I know I've taught you that, but those were not word problems. Those were just straight up graphs. Now we're graphing in word problems, and we need to interpret our graphs or graph in context of the word problem. So I know that and really I should use R and T to be honest with you. So this is my T. How do I know to put T here? Because R is all by itself. And Y is what's usually all by itself. So my R is going to be in place of my Y, and my T is going to be in place of my 6. So a T here and an R here. So when my time is 0, I haven't taken off yet. What's my speed going to be? 0. Now if you don't believe me, come over and do this. Put a 0 in for T right here, okay? If you put a 0 in for T, you can probably do this in your head. 0 minus 6 is negative 6. What's the absolute value of negative 6? Positive 6, but you got negative 10 on the outside. Positive 6 times negative 10 is negative 60. Then bring down your positive 60 and you get out 0. So trust me, you will get out 0. Alright? Now, we know how this, as long as the gap from here to here is the same as it is from here to here, then this number here is going to match this number here. So, here's what I'm going to do. I'm going to say I went from 6 to 0, or 0 to 6. So I'm going to put a 12 here, that way my gap's the same, okay? So at 12 seconds, guess what I'm back down to again? 0. Watch. Put a 12 in here. 12 minus 6 is 6. The absolute value of 6 is 6. Negative 10 times 6 is negative 60. Bring down your positive 60 and you get out a 0. Okay? So, let's review. The first thing I did is found the vertex. I put it right in the middle. That's easy. Then I said to myself, I want to go back to the starting point. So the starting point is when I was traveling 0 seconds. My car had not moved yet, so I put a 0 in. At 0 seconds, I was traveling at 0, a rate of 0. Now I realized my gap here was 6. So if I'm going to go 6 back to 0, then I'm going to go from 6 up to 12 to get a balanced table of values, and I get 0. So my graph here, my x-axis, or in other words, my t-axis, I'll put a T right here and an R right here. My t-axis goes from 0 to 12, so I can squeeze 12 points in here. There's my 12 points now, or 12 tick marks. My rate goes up to 60, so I'm going to have to use probably increments of 10, 10, 20, 30, 40, 50, 60, and yes, you can use different increments on the different axes, definitely. Okay, so 0, 0, 0, 1, 2, 3, 4, 5, 6, up to 60 here, and then 12, 0 down to here. So my graph would look something like this. There it is. So we graphed it. Now, how many seconds did it take for you to reach the second light? Well, guys, 12 seconds. Come on, think about this. Think, okay? At 0 seconds, you had not taken off yet. 6 seconds later, you hit what rate? Not 60 miles per hour. You're dealing with feet per second, okay? So, at 6 seconds, you reached a speed of 60 feet per second, and then you started slowing down. That's your vertex right here. Then you started slowing down, so you sped up, boom. Then you start slowing down. At 12 seconds, what is your speed? 0. So if you're sitting still at 12 seconds, then that means it took you 12 seconds to get to one light. You started here at one traffic light at 0 seconds. You went up for 6 seconds, then started slowing down for 6 seconds, and boom, you're right here. So it took you 12 seconds to reach the next stoplight. Not super easy to understand, I know that. And if you're struggling with that, just wait till we get to number 58. Okay, but it's still reasonable if you'll think about this. It does make sense, okay? Now, what is the distance between the two lines? This is going to be interesting, okay? Very interesting. So let's think this through for a second. Okay, students, back. I had to pause the video. Whenever I come across a problem that I know is going to take a little explanation, I like to pause the video and make sure that I'm just explaining it, hopefully very well, first going over it in my mind. Now, here's the deal. Now, watch this so very carefully, please. This is tough to see, and I probably would not give you one of these on a test or a quiz, but I might. But let's at least pay attention and try to get this, okay? Some of you will understand, some of you won't. R is your feet per second. That's your rate. Got it? Feet per second. Alright? So at 1 right here, my rate is about 9. So I'm going 9 feet per second at that point in time, okay? So for that 1 second, I'm going about 9 feet. Now, same thing here with 2. 2, I'm going about a rate of about 18 feet per second. I'm just estimating because this point right here, even with 2, is even over here at about 18. This point here that was even with 1 is even with about 8 or 9 right here, okay? So it's the same thing we did earlier back here when we found the area under the triangle. It's the same thing. Guys, the reason I'm saying it's hard to see is they're asking for the distance. I'm trying to explain to you how the area gives you the distance. It's like going up to here at so many feet, going up to here at so many feet, up to here at so many feet. So you're basically, once again, finding the area of the triangle, okay, to find the distance between the two lights. Now, remember, this was your time. So if I asked you any question about the time, you would look at the x values. If I asked you anything about the speed, you would look at the r values here, the rate or the speed in feet per second. But I'm asking you here for the distance, and that's going to be the same thing as finding the area of the triangle. So once again, we know how to find the area of a triangle. 1/2 base times height. 1/2 times the base. Well, the base goes from 0 to 12, so my base is 12. The height, well, I go over 6, and then I go up 60 to get to 660 over 6 up 60. So the height is 60. So if you multiply these together, you will get 360 feet, which is the answer. How do I know it's feet? Because my rate is in feet per second. If it would have been miles per hour, then this would be miles. Okay? Alright, moving on. Okay, the Trans-American Pyramid is an office building in San Francisco. It's about 850 feet tall. It has about 160 foot wide. It's about 160 feet wide at its base. Now, I did not take the picture of it because there really wasn't a lot of room to put it on the page. Plus, it tells you that it's shaped like a pyramid just in the name alone. So, if you want to turn over in your books to page 106, you're welcome to do that. You'll see a picture of it. For me, I'm just going to draw a picture like this and be done with it. And I just always kind of hesitate to draw pictures like this because I always want to remain humble and not show off my amazing drawing skills that I have. But nonetheless, I will go ahead and show off at this time. So here is like a picture of the Trans-American Pyramid in San Francisco. Never been to San Francisco, would love to go sometime. And maybe that will happen. Now, what is the slope of the side of the building? Well, students, I've taught you, anytime you're trying to find the slope of a line, if it's a graph situation, we're going to use rise over run. So you take this point here at the end of the line and this point here and you make a right triangle. So we go over and straight down. We've learned that over and over, guys. That's how you find the slope of a line. Rise over run. So this is my rise and this is my run. Now, they told us the entire base is 160 feet wide. So I know from this point here over to this point here, this whole base is 160. Got it? So half of that would be 80. So my run from here to here must be 80. My rise is right here. It's 850 feet tall. So my rise is 850. Okay? So I'm going to clear all that off so we can do some work on this in a second. So here we go. Let's get rid of all these markings. And so my rise was 850 and my run was 80. 10 goes into both those numbers, so reduce it, and there's your slope, 85 over 8. Okay, rise over run. Now the last question on this type of problem here, imagine that a coordinate plane has been superimposed over a head-on picture of the building. In the coordinate plane, each unit is 1 foot, and the origin. Now remember, the origin is where x and y axes intersect right there. That's the origin, 0, 0. The origin is where? Where is it? At the center of the base. At the center of the base. So let's go ahead and do that. So look again at the problem. It says the origin is at the center of the base. So I'm going to put my origin. We'll use the color black here. The origin goes right here at the center. So here's my y-axis coming across. Excuse me, my x-axis, sorry. And here's my y-axis coming straight down. Alright. There we go. Now, they want us to do what? Write an absolute value equation whose graph is the V-shaped edge of the building. So, we're going to write an absolute value equation for this part right here. I really don't think this is too difficult. First of all, I know the vertex right away. You do, Mr. Earhart? Of course I do, guys. Look, this point right here is even with the origin, so I'm not over to the right. I'm not over to the left. I'm right at 0. How high up am I? Well, the height is what? 850. So there's my vertex just like that. So if I'm writing an absolute value equation, this number here always goes on the outside of the absolute value. Remember that? So I'm going to put plus 850, your y value goes on the outside of the absolute value. We know that. In other words, if I gave you an absolute value equation like this, you could find the vertex very quickly. The vertex would be 5 comma 6, because you take the inside here, set it equal to 0 and solve, and you get 5, and this number here goes right here. So 850 is your y value, just like the 6 is. It goes on the outside. Now, we have an interesting dilemma here. We have 0 for the x value. Well, that actually makes it really easy. Just put an x here. Think about it, guys. If right now you take this inside and set it equal to 0 and solve, you would get x equals what? 0. There'd be nothing to do. That's it. You're done. So hopefully, that's kind of tough to see. Hopefully you see that. So inside the absolute value would be x. Now here's something you did not know, but I'm going to teach it to you now. The slope of this line, which by the way is the exact same slope as this line here, just a different sign. The slope always goes on the outside of its absolute value. Now I've never taught you that, but now you know that. So the slope was 85 over 8. Remember, we found that earlier. So right here I'm going to put 85 over 8, and then something else. If your phi is opening upward, this will always be a positive number. If your phi is opening downward like this one is, then this here will be a negative number. So we know this has to be a negative number right here. So I'm going to slide this over and get a little room and put a negative sign right here. And there we go. Now some of that was new, but that's okay. Guys, we're learning as we do word problems. It's great, okay? So you just wrote, in the past how we've learned how to write absolute. In the past we've learned how to write linear equations, right? We've used this model here. And we've used this model here to write linear equations. I mean, we've done that. You should know how to do that. We have written linear equations. Well, this is pretty exciting. We just wrote our first absolute value equation. There it is. We took a graph and we wrote an absolute value equation. Pretty cool. Okay. All right, moving on. Last problem. We're finally finished. I'm going to go through this very quickly, guys. We all know by now how to write linear equations. They're just telling us between 1920 and 1990 improvements in poultry science. Produced hens that laid more eggs. And they've given us an equation here, or a model here, a graph. Find an equation that you think best fits the data. So look, guys, I've taught you. Just kind of draw a line through the main part of this ordered pairs and pick a couple points, one toward the beginning, one toward the end, that falls near the line. So I'm going to grab this point here, and I'm going to grab this point here. Okay, so having said that, let me pull this line out of the way if I can. I'm not sure how many pieces there is to it. Probably quite a few. That's okay though. That's not good. Now, I've chosen those two ordered pairs, so we're just going to estimate them. 45, let's see, we're going by 30, 15, 45. This would be 60 right here. 75, so we're over here. I said it's about 63. So this ordered pair right here is over 63. And it's up 1, 2, 3, 4. I'm going to put 4.5. I really don't want to use decimal. I'm not going to do that, guys. On a test or a quiz, I will let you pick whole numbers. I'm just not going to waste time using a bunch of decimals. I'm just going to put a 4 for my y value. Okay, now this point here is over about 15 on the x. And it's up right in the middle, so we're going to say 2. Alright, so there's my two ordered pairs. So whenever you have two ordered pairs, what model do you use? Well, this one right here. Right, we've learned that. So we must find the slope before we can use this model. So y minus y, 4 minus 2. X minus x, 63 minus 15. 4 negative 2 is 2. 63 negative 15 would be 48. Reduce that and you get 1 over 24. So your slope is 1/24th. Okay? Now, it does not matter which ordered pair you use. I'm going to use the one that has smaller numbers. That's just me. It doesn't matter. So I'm going to use this ordered pair here. This is my x. This is my y. So y minus 2. And then for m, I'm going to put 1 over 24. X minus 15. So y negative 2 equals 1 over 24 times x is 1/24th x. 1 over 24 you have y equals 1 over 24x. Then you have a negative 15 over 24 and a positive 2. Now please learn how to use your calculators. Your calculators will help you so much. Right now on my calculator screen, I'm going to type in negative, here's my calculator screen, I'm going to type in negative 15, and then divided by, and then 24. So your screen should look like that. Alright. Then I'm going to hit plus 2. So then it should look like this. Then hit enter, and you're going to get this. It's going to say 1.375. Now look to the left of your calculator, the left column, third button down from the top says math. Hit math, enter, enter, and you should get 11/8 will appear right here. And there you go, you did it. That will save you so much time. So my answer is y equals 1 over 24x plus or positive 11/8. And there I did it. This is a decent representation of the scatter plot right here. Now, Mr. Arrow, could we practice doing this problem with our calculators, the linear regression formula or calculus? You could, guys, but you'd have to enter every single one of these points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, to about 15 points. That's going to take a while. Plus, a lot of them are going to be decimals. To be honest with you, if I give you a problem on your test or quiz where you have to use, on a test or quiz where you have to use a calculator, I will make sure it's about 5, 6, maybe 7 points. That's about it, to save time. Okay, I hope this homework help video has been a help to you guys. If you have any questions, never hesitate to call